So this last example is not in your book, but it's something I wanted to mention. Rates of change according to Rocket Man Ralph.
Who's that?
Okay, Rocket Man Ralph is the guy that I just invented yesterday or on Friday when I was making these notes.
Rocket Man Ralph.
Okay.
Rocket Man Ralph.
There you go. Rates of change.
Yeah.
Okay. So imagine you have a little Rocket Man here. Okay, I'm going to attempt to draw Rocket Man Ralph. Okay. So here's Rocket Man Ralph.
He doesn't have a cape.
And he's got
He doesn't need one. He's Rocket Man.
He's got a jetpack on his back
Wow, that is so cool.
with some fire coming out.
Looks like a college dry.
Okay. And of course he's got a safety helmet because you can't rock it without taking safety into consideration.
You gotta put a stripe on the film.
Okay. Where's his eyes? I just draw his eye on the top of his head. There we go. Rocket Man Ralph takes different paths of flight. Oh my goodness. Okay. I'm just using this to show you different kinds of rates of change. Okay. Think of this like you could think of it as distance versus time, or even speed versus time. It kind of indicates the same thing. But the point is, when you see a line, or if you see Rocket Man Ralph flying in this direction like that, if you have a straight line, that indicates a constant rate of change. Okay, so if you're talking about distance versus time, that means that you're going at a uniform speed. You're gaining the same amount of distance over each time interval. If you're talking about speed versus time, then the speed is increasing at a constant rate. You're accelerating at a constant rate. Okay? Point is, when you see a straight line, that should imply a constant rate of change. Okay? Which becomes very, very important, especially if you study physics. Which you all will, right?
We're doing that next year, right?
Hopefully. Okay, so that's constant rates of change. Just erase that here. Now we have a rate that looks like this. We've got Rocket Man Ralph traveling in this direction. What kind of change is occurring in this case? It could look like this. It could also look like this.
You get to a high and then it kind of levels off.
Yeah. There's like a very quick increase here, and then that increase kind of tapers off as I go along. Or there's a very slow increase initially, and then that increase starts to speed up as I go on.
Jesus fish.
So this is just called, yeah, it's the Jesus fish. Okay? This is just called a rate of change that is not constant. Okay? So rate of change that is not constant. So examples of this could be things like if it was distance versus time, you accelerating. Okay, you gain a little bit of distance at first because you're not going very fast, and then that amount of distance covered increases as time goes on, as your speed increases. Or if it was speed versus time, then your acceleration rate is increasing. Okay, so picture like your foot just kind of lightly pressed on the pedal, and then you just gradually floor it. That will increase the rate of your constant acceleration, which affects your rate of speed as well. Point is, when you have a curve, there's not a constant rate of change. That rate is changing as time goes on. Okay? Last one. Is a flat line. Oops, that's going down a little bit. Flat line, there we go. What would that indicate? What kind of change would that indicate?
No change?
No change.
Isn't that constant?
Or constant. Technically, constant can mean no change as well. Right? So there's no rate of change. So give me an example. If this was distance versus time, what would that indicate? This was distance and this was time. You're not going anywhere. You're standing still. What if it was speed versus time?
You're in like a car on the highway.
You're traveling at the same speed or at a uniform speed.
Cruise control.
Cruise control is a good way of putting it.